Wow, welcome once again to Mathematics Meal. Today on Mathematics Meal, we have a hot cake to enjoy. I know we have been enjoying mathematics pizza for a long time, but today we want to shift to what? To a hot cake. This hot cake is coming from the oven of logarithm combined with what? Indices. You are going to like this hot cake. Subscribe to our YouTube channel and make sure that you follow us on Facebook at Mathematics and Science Meal. So if you are ready now, let's begin. Now we have a question. We are asked to simplify 2 raised to power log 3 in base square root of 3 times, so all these are multiplying, times 18 raised to power log 3 in base 6 times 2 raised to power log 1 over 2 in base 6 also. So we are asked to simplify this. Now there is no direct law of indices that we can apply here to combine all these powers. We don't have any direct law of indices. So we need to think outside the box. We need to think outside the box. The major problem we have in this question are the powers. So if actually we can simplify these powers, then we will not have problem trying to simplify this question. So we will look at the powers and see how we can deal with them. All right. Then the second issue we have is that we have this as 2 and 2, but here is what? 18. We must look for a way to see if we can actually introduce 2 here. So these are the things we need to think about if we are going to solve this problem. Remember, anytime you are trying to solve problem in indices or in logarithm, we have basic laws that we use in solving problems in indices and logarithms. But in a situation where these laws cannot be applied directly, then we look for other means. Maybe we use substitution, or we modify the expression in such a way that the laws can now be what? Applicable. So let's look at these questions together. I know many may be thinking, how are we going to eat this hot cake, seeing that it is hot? Actually, it is hot, but we are going to enjoy it together. Yeah, cake is even better when it is hot. Don't mind me. So let's look at this together now, the solution. So we have 2 raised to power log 3 in base square root of 3 times, let me put dots, or let me just write it as it is here, 18 raised to power log 3 in base 6, then 2 raised to power log 1 over 2 in base 6. Now looking at this power I can decide to write this power in this form. Log 3 in base square root of 3 can be written as log 3 in base 3 raised to power what? Half. Because square root of a number is the same thing as that number raised to power of half. If you look at the laws in fractional indices, you will understand that. So I can write this in this form. So that means I will have 2 raised to power log 3 in base 3 raised to power 1 over 2 times, now 18. I can use similar power law. We know that a raised to power m divided by b raised to power m is same thing as a divided by b all raised to power what? M. Right? And which I can go further to write as a over b all raised to power what? M. So this 18, I can write 18 raised to power log 3 in base 6. I can write it as 36 divided by 2 raised to power log 3 in base 6. I can write this 18 like this. Why? 2 divide 18 will give us what? 2 divide 36 will give us what? 18. When 2 divide 36, we still have 18. So it means that I can write this 18 raised to power log 3 in base what? In base 6. I can write it in this form, 36 divided by 2, because 36 divided by 2 will still have 18, so nothing has changed. So I can use the whole of this to replace 18 in this expression. So let's go again on that. So we'll have, can put it like this, times 18 now is 36 divided by 2 raised to power what? Log 3 in base 6. Then times 2 raised to power log 1 over 2 in base 6. Okay. Then, since I've written this like this, I can also express it in this form. In these forms, rather. Yes. As A over B. So this will be 36 over 2. So if we go further here, we can write this as 2 raised to power log 3 in base 3 raised to power half. Now you look at this again. We have a law in logarithm. If I have log A in base B raised to power n, the same thing as 1 over n log A in base B. So when the power is on the base, it's the same thing as writing that power as the what? Reciprocal of the coefficient of what? Of the log. So n moving to this side becomes 1 over n. So that's what it means. So we have this power on this base, half. So if we now take the reciprocal of half, the reciprocal of half will be what? Will be 2. So this now, having log 3 in base 3 raised to power half, if I rewrite it, is going to be 1 over 2 log 3 in base 3. Now 1 over 1 over 2 is actually 2. So the reciprocal of half, that's what will come here, which is 2. So this will now become 2 raised to power 2 log 3 in base 3 times, then I can write this as 36 divided by 2 raised to power log 3 in base 6 times 2 raised to power log 1 over 2 in base 6. Okay? Things are becoming clearer to us gradually. So let's continue. Okay. Now, applying similar power law. If we apply similar power law here, we can separate this power. This power is for 36 and also for 2. Just like we have here, a raised to power m divided by a raised to power, b raised to power m is same thing as a over b all raised to power m. So from here, I can still distribute this power to this and this. So it also means that this is a raised to power m over b raised to power what? M. That's from here, actually. From here, when you say a raised to power m divided by b raised to power m is same thing as a over b, or a raised to power m divided by b raised to power m. So that's what I want to do here now, since the power is for both 36 and 2. So, but I need to simplify this first. Log 3 in base 3 is 1, because the fourth law of indices says that the logarithm of a number to its own base is actually 1. So we are going to have this to be 2 raised to power 2 times 1. Where is this 1 coming from? From log 3 in base what? 3. Logarithm of a number to its own base is 1. So we can now write this as 36 raised to power log 3 in base 6 all upon 2 raised to power log 3 in base 6 times 2 raised to power log half in base what? 6. Okay. Alright. So if we move further, already this will reduce to, this will reduce to 4. Because 2 times 1 is 2. So 2 raised to power 2 is actually 4 times. I can write this in powers of 6. 36 is 6 raised to power 2. So instead of 36, I can write this as 6 raised to power 2. And then we have this power log 3 in base what? 6. Divided by 2 raised to power log 3 in base 6. 2 raised to power log 3 in base 6. Then times 2 raised to power log half in base 6. Now I can see these two, so I can write them together and then apply the law of indices. So let's see what we can possibly do. So let me rewrite this now, since this is multiplying. So this becomes 4. We are continuing from here. 4 times 6 raised to power 2, let's give some space, 4 times 6 raised to power 2 log 3 in base 6 times 2 raised to power log half in base 6 divided by 2 raised to power log 3 in base 6. Okay, now why I have to write these two together is because they have the base are the same, the bases are the same, the base here is 2. So I can apply the law of indices here. How? Let me rewrite this again. I will have what? Using the law of indices, let me rewrite this. I can write 4 times 6 raised to power 2 log 3 in base 6 times, this is something as saying 2 raised to power log half in base 6 divided by 2 raised to power log 3 in base 6. That's what this means. Yeah, that's exactly what it means. So, because of this, you remember that in indices, a raised to power m divided by a raised to power n is something as a raised to power m minus what? Minus n. Wow, this cake is really hot. Let me take some water. If you are watching me, you can still take your own water. The cake is really hot. I can feel it. It's really hot. So let's continue. So if we remember from the second law of indices, a raised to power m divided by a raised to power n, that is something as a raised to power m minus n. That's the second law of indices. The bases are the same, and the operation here is division. So we subtract the power under a common word, a common base. So that's exactly what we have here. So we have 2, the same base, the operation is division. So we're going to subtract these 2 powers. So if we do that, we will have 4 times 6 raised to power 2 log 3 in base 6 times now 2 raised to power log half in base 6 minus log 3 in base 6. Now let's simplify this using second law of logarithm. In second law of logarithm, we know that log in base b m over n is something as log m minus log n base b. So we have this now. The bases are the same. The operation is subtraction. So if we apply this second law, we are going to use this 3 to divide what? To divide 1 over 2 here under the common logarithm. So if we apply that law here, we are going to have 4 times 6 raised to power 2 log 3 base 6 times 2 raised to power log in base 6 1 over 2 divided by 3. 1 over 2 divided by 3. That's beautiful. Okay. Now 1 over 2 divided by 3, because we want to show everything, 4 times 6 raised to power 2 log 3 in base 6 times 2 raised to power log 1 over 2 divided by 3 will give us 1 over 2 times 1 over 3. That's what we'll have. 1 over 2 times 1 over 3. That's what we're going to have. So, if we do that, then we'll now have 4 times 6 raised to power 2 log 3 in base 6 times 2 raised to power log 1 over 6 in base 6. Because 1 times 1 is 1, 2 times 3 is what? 6. So we have this. We can go further. Yes, we can go further here. You see, this, we have simplified this. If we simplify this, then our business will be to deal with this. We're coming to that. Let's see how we're going to deal with this man. Wow. We still need to clean this part of the board because we are going to take up some spaces more. So we have this log 3 in base 6 times 2 raised to power log 6 raised to power minus 1 in base 6. 1 over 6 is the same thing as 6 raised to power minus 1. Okay, we have to continue. I leave the equation. I will not clean the equation. So let's continue with our solution. So So what do we have from there? We can easily write this as 4 times 6 raised to power what? 2 log 3 base 6 times 2 raised to power minus log 6 in base 6. Why? When the power is on the number, it's same thing as the coefficient of the logarithm. You remember the third law? Log m raised to power p in base b, same thing as p log m in base b. So the power is on the number, so it becomes the coefficient of the what? Of the log. So the power here is minus 1. So when minus 1 multiply log, we have minus log. So, wow, we're almost there. Just take your time. So we have 4 times 6 raised to power 2 log what? 3 in base 6 times 2 raised to power minus 1. Log 6 in base 6 is 1. Logarithm of a number to its own base is 1. Oh, this is nice. So we move further. This becomes 4 times 6 raised to power 2 log 3 base 6 times 1 over 2. Okay? That's what we are going to have. Because 2 raised to power minus 1 is 1 over 2. Now 2 can comfortably divide this. So we are left with 2 times 6 raised to power 2 log 3 base 6. Someone may say, let's stop. We are tired of this. Let's stop. But we are not going to stop. We are not going to stop. So let's go further now. This is where our problem is. Now let's see what we can do with this power now. Let's see what we can do. I can say, let 2 log 3 base 6 be y. If this is y, then what it means is that the whole of this is what? Is y. So I can write it as 2 times 6 raised to power what? Y. Okay? Okay, let me see if I can simplify this. So 2 log 3 base 6 is equal to y. If I take these 2 here, I'll have log 3 raised to power 2 in base 6 is equal to y. Okay? 3 raised to power 2 is 9, so I can say that log 9 in base 6 is equal to y. Now, in indices, when we take the base of the, in logarithm, when we take the base to the other side of the equation, when we have logarithmic equation of this form, when we take the base to the other side of the equation, any term here will become the power of the base. So when we remove the log, so we can write this as 9 is equal to 6 raised to power what? 6 raised to power y. Take the log, the base here, the term here becomes the power of the base, then take away the logarithm. If you watch our video on theory of logarithm, you will understand this law. So 6 raised to power y is what? 9. So we have 6 raised to power y here, beautiful enough. So if we now use 9 to replace 6 raised to power y, we have 2 times 9, and finally our answer becomes what? 18. Wow. What a hot cake. It's actually a hot cake. I will give you time to just take this cake and also digest it. Till I come your way next time, we'll still have our pizza. We'll still be having our hot cake. Remember, always visit our platform on YouTube, Mathematics Mail 1, and then on Facebook at Mathematics and Science Mail, and then also visit Engineer Ike Okechukwu and also follow Engineer Ike Okechukwu on Facebook so that you have time to enjoy our meals, both in physics, in chemistry, in biology, in mathematics, in all the sciences. We have a lot of meals that can keep you healthy in mathematics and in sciences. Thank you for watching our video. Till I come your way next time, continue to enjoy our meal. I still remain your friend and your brother, Engineer Ike Okechukwu. Thank you.